Recalling from our early days of math, we learned that there's a formula to find the distance traveled by an object. Distance was equal to rate times time. So for example, if we started at 2 o'clock in the afternoon going 60 miles an hour, and at 6 o'clock we were still going 60 miles an hour, we're on cruise control, which means that during those 4 hours we had a consistent rate of 60. So I'm going to call that a velocity. Velocity is just a speed with a direction. We're going to call that 60. And think about that. That's kind of like the line y equals 60 on a graph like this, okay? But we're looking from 2 to 6 as the time change. So if I found the area of this rectangle, that would equal the total distance traveled, 240 miles, 60 times 4. Now, if the velocity varied, we might get, instead of a constant graph like y equals 60, we might get a graph that goes all different velocities, all different speeds. So then we have different kinds of rectangles to choose. We could choose a rectangle to approximate this by taking the middle of an interval. So there's a rectangle area. Then we could take another rectangle area at the middle of the next interval, which would be at this height right here at 3.5. So the first one was at a height of 2.5. We take a height at 3.5, which would probably give me a rectangle, let's say about this size. And then if we use another rectangle at the height at 4.5, we could get a rectangle here. And finally, if we use the height value, the y at 5.5, we could get another rectangle. And by adding these rectangles together, we get a reasonable approximation to that area, like we used area over here. If I add up the 4 rectangles, I'm going to get an approximation for the total distance traveled with a variable velocity. We're going to look at another example where instead of using the middle of the interval, we're going to use the left side of each interval. Then we're going to do one where it's the right side of each interval to get our 4 rectangles. And finally, we're going to use calculus to give us the exact area, which is going to be something called an integral.